So very good afternoon to all the participants. As the drive is already shared with you, the entire course content drive is with you. This SDP3, AI and ML. You can access the day 9 content from here inside course content. You have to go day 9 folder. So I request you to please download the dataset.zip from this particular folder. I'm also downloading so that we will, until we will have the introduction of today's lab, you will have the downloaded version of this dataset. So kindly download this dataset from the day 9 folder of the shared drive. The entire content with the required files, the dataset, and the Python notebook is shared with you. So this is the Python notebook, Artificial Intelligence and Machine Learning, YOLO V4. You can download this also, but there are many changes that you have to perform while successful execution in your drive. Neha ma'am, can you please share the drive link again? So this is the notebook, which contains the required steps to run object detection model using official YOLO V4. So YOLO V4 is a version of YOLO that is you only look once. The current version of YOLO is YOLO V7, which is in PyTorch. So if you want to run that is also available in the official repository by Alexi AB. So this is the performance of average precision versus the frames per second. So you can see YOLO V4 is able to achieve the highest when compared with YOLO V3, V4, EfficientNet, and other models. The initial version of YOLO were introduced, like YOLO V1, 2, 3 were by Joy Redmond, but because of the consequences and the cons of the AI improvement, he stopped research in the domain of computer vision. And then to have the legacy of this YOLO, Alexi AB and his team has working on YOLO V4 and the successor models. So I think all of you are able to download the file. Next step is in your drive, anywhere in your drive, you have to create a new folder. And in that particular folder, you have to upload a new this dataset.zip file. So I'm creating this folder, new folder. Day 9 AI ML. Please follow these steps if you want to run the model in your system. And then upload the dataset.zip file here. So this is the file, dataset.zip. Please upload this file in your folder and also create a new notebook in your same folder you have created. I'm creating a new notebook by clicking on, I think this step we have done in multiple labs. So this is very easy. Click on plus new, go to more option, and then Google Collaboratory. So it will create a new Google Collaboratory notebook in this particular folder. If you don't see Google Collaboratory here, you have to add a new app. By searching in this search menu, it will be appear after some time. Maybe because of some internet issue, it is not opening. So in this search apps option, you have to search for Collaboratory. And then you have to install this in your drive. In my case, it is already installed. So once you have installed the Collaboratory, by clicking on this plus new more option, you will search, you'll find that Google Collaboratory is there. A new notebook will be created with name as Untitled 0 here in this particular folder. As you can see, it is showing that the dataset will be uploading in 37 minutes. In maybe for many of you, it has already been uploaded. So it depends on the internet availability, that how much time it will take to upload the dataset. I'm renaming it as YOLO V4. The very first step is you have to rename the Python notebook. And then the second step is, as we are working on object detection model, which is huge and requires a large size of data and training as well, you need to change the runtime, the processing power from CPU to GPU. So I am changing from runtime menu, I am changing it to from hardware accelerator none to, that is CPU to GPU. It will allot you GPU of 3 types, either T4, that is Tesla 4, or A100 or V100. So I'm setting it as by default, that is T4, or you can change it to A100 or V100 GPU processor, and then saving it. Now we have changed the runtime type. Next is you have to connect your drive. So I'm clicking on this connect button. Please do all these steps. I am waiting for all of you to complete these steps. When you are done with these steps, you can respond in the chat box, or if you have any query, that also you can write in the chat box. Shubhangi ma'am is there. She will help you with the answers if you are facing any issue. Whenever you are done with these steps, please respond. So 2 participants has completed. The steps are already there in the shared. If you are not able to follow the steps, you can open in a new tab, you can open this shared Python notebook. All the steps are there. First of all, you have to upload the data set. The second step is up to mount, change the runtime type. From change runtime type, make it GPU. These are 2 very basic steps that you have to follow. Next is, as we are, this Google Collaboratory is going to provide you the storage, which will be deleted after 12 hours. So it's better to store the data or partial results or the end result in your Google Drive. So for that, you have to mount your Google Drive so that you can access the storage of your drive. So to mount your drive, you have to click on this files menu and then this mount drive option. Please do the steps in your drive also. Connect your drive to your mail ID, give the permissions. Mount your drive. This step also you have done in earlier labs. So you can see in my case, drive is now mounted. I'm clicking on this drive, going to the folder, this particular folder, day 9 AIML, so that all the files and folders will be stored in the newly created folder. Please follow this step also. After mounting your drive, you have to reach to the place where you have created the folder. In drive menu, click on my drive, and then whichever folder you have created. In my case, I have created this day 9 AIML. I am right clicking on this particular folder and then copying the path. Go to the place here where you have created the folder, right click on the folder and then copy the path. Then next is you have to change the current working directory, as the this collaboratory provides you Linux environment. Yeah, you can run all the commands which are available in Linux. So %cd, that is change directory, and then control V to paste the path. Copy the path of the folder you have created, and using cd command, change the current directory. So the steps was, first you have to change the runtime. Second, you have to connect to the Google Cloud to access the GPU services. Third is mount your drive. Fourth is change the current directory to the folder which you have created in your drive and where you have uploaded the dataset. That is dataset.zip folder file. So it will take some time. Meanwhile, we will do other steps. I think up to this part, all of you are able to do. Please respond, because next step is you have to access the official YOLO package, and then we will make some changes in that particular YOLO code to run it on the custom dataset. So we will wait for some time so that those who are not able to do it, they can also follow the steps. If you have any query or you are facing any issue, you can write in the chat box. So we are going to use the official YOLO v4 GitHub repository. That is why LXCAB. So till now, we have not imported the dataset. We have just mounted the drive. And next is we are now cloning the darknet. You can see this is the darknet repository. To clone this particular repository, you have to click on this code and then copy the path. I'll paste the path in the drive, the chat box as well. So after changing the current working directory, next is you have to clone the repository. So git clone, and then I'm pasting the git directory. And again, I am pasting the entire command in the chat box. So either you can click on the link of this darknet, or you can open a new tab to access the path of this particular darknet, or you can type it git clone and then the path of the darknet git. So there is a query why we are doing this command and cloning. The official YOLO v4 is basically with Python, C and C++. To run YOLO v4, the official YOLO v4, you have to follow these steps. So that's why we are cloning the official YOLO v4, or you can say darknet framework. So in my case, cloning is done. Once you have cloned the darknet, you have to comment this particular line. So to comment, you have to use control and then / button. When you will clone the darknet, you will see inside the Day9 AIML folder or whichever folder you have created, a new folder will be created after cloning named as darknet. It will be having multiple files and folders in it that will be helpful to run the YOLO V4 model on your custom dataset. Either you can run ls command to see that darknet folder is there. This is the folder. This is our dataset which we are going to use. I think all of you are able to upload this dataset.zip. If you have uploaded, please respond in the chat box so that the next step is unzipping this dataset. That will also take some time so that whenever you are done with this unzipping, we will replace it with the path where we need the dataset. Divyanshu is okay. So I think many of you are able to upload this dataset.zip. As this is a Linux environment, you have to just unzip it. Unzip command is there. Use exclamation mark, unzip, and then dataset.zip. So it will unzip the file. With this particular file, you can see it has created a folder dataset, and it will be having multiple images with the corresponding annotation. So next is I'll explain the dataset. After unzipping, you have to comment this line again, because once you have unzipped the dataset, no need to unzip it again. Please run exclamation mark unzip space dataset.zip. We are waiting for a minute so that you can also do these two steps, cloning and unzipping. There is a issue error showing that cannot find or open. First of all, run this ls command so that you can check whether dataset is .zip is there in the current working directory or not. If it is not there, then you have to check the path where you have uploaded this zip file, and then you can do it. So again, nothing in the output window. No issues if it is not showing anything after unzipping. Please check in your directory whether dataset folder is created or not. In my case, dataset folder has been created. So you can see dataset folder is there. Check your drive after unzipping. If it is not there, dataset.zip, rerun the command. You have to run this command without hash. Unzip space dataset.zip. If you don't have dataset.zip in the current working directory, you can do the same step. Go to the place where you have uploaded dataset.zip, right click, copy path, unzip space, paste the path, and then run it. That is again the same command. Only instead of direct path, we are providing the relative path. So after this unzipping, you will have a folder dated. When you go inside the folder, you will find out that there are some 96 files. 96 files are there which are having images in the form of PNG. 48 images are there, and 48 text file, corresponding text files are there. When you will open any of the image, this data set contains two type of object. One is tiger and another one is peacock. So we have downloaded the images from the internet and then we have labeled these two objects, peacock and tiger, and then to label the images, you will be having a software. There are multiple softwares available, but one which we are using is Label IMG tool. There is issue, ma'am. I unzip this profile. If you have uploaded after unzipping, there is no issue. I have not uploaded the unzipped folder because it takes time to upload the folder instead of files. So we are using Label IMG tool. It is a software which helps you to create bounding box annotation, which is in two format. One is YOLO format and another one is Pascal VOC, that is XML format. So this is the software. This is the software Label IMG. You can install it. All the steps are here, which you can follow to install. Pip3 install Label IMG if you are using Python in your local system, and then you have to write Label IMG and it will open the software. Let me try if I can show you this also. So I'm creating in the desktop, I'm creating a new Python notebook to check Label IMG is opening or not. In my system, Label IMG is already installed. You can install it by pip install Label IMG or pip3 install Label IMG. After that, you have to just type Label IMG to open it. So you can see this is the software. So you can, if you want to annotate your images, you can open the directory. There is some error. Let me rerun the software. Anywhere, if you have some images in a folder, you can open the image, and then using this create rect box, you can create the rectangular box. Name the class and it will be created a new box. There are multiple options available which you can use further. You can see two peacocks are there, so I have created two bounding boxes. Then wherever you have this particular folder, I have created inside YOLO V4. So inside YOLO V4, test images are there. when you will save it, this is the button for save. Whenever you will save it, you will see that a corresponding text file will be there. It is there in download, YOLO V4, test image. And I'm changing the next is, if you want to change the image, you can click on, and then you can also edit these boxes. Suppose I want to delete these boxes, I can do it. I can change the proportion of these boxes in the software as well. So you can see two files are there. One is classes, which will be having the class names. So there is one class, so Peacock. If there are multiple classes, the next class name will be in the next line. So it will be line separated file. This classes will be a line separated file. And then for each image, there will be a corresponding text file. So this, and the name of the image and name of the text file will be same. There were two boxes in the image, so it has created two annotation. 0 is the class, because Peacock is the first class, so 0. If the second class is Tiger, that will be annotated as 1. These are the 4 bounding box annotation. The next 4 things are bounding box annotation. That is center, X center, Y center, and then height and width of the box. And this is again same, height, width, X center, Y center. So after annotating the 48 images, we have the images as well as corresponding text files with us. And I think all of you are able to upload these files. If you want to create your own data set, you can use this particular software. Up to this part, if you have any query, please write. Link of label IMG tool. Okay, I'll paste the link of the tool. Next step is you have cloned the software or the code of Darknet from the official repository. Now you have to make an executable build of this this particular git clone file. So to first of all, you have to make some changes in the make file. So make file is to create a executable build of the cloned Darknet. So this is the file, make file. You can either download it. I'm downloading this make file. Two things you can do to run these steps. Either you can download this make file, or you can, using set command, you can make the changes in the file. So this is the make file. I'm opening it with the notepad. You have to make GPU is graphics processing unit, make it 1. CUDNN is a library which helps you to use the GPU services in your code. And then third is OpenCV, which you know that OpenCV is image processing based library, Python library. So you have to make these 3 packages in place of 0 to 1 to enable the services. This is the one step. And then you have to again upload this make file in the Darknet folder. You can either do this particular step, or you can make the changes using SED command. So I'm writing those SED command also, and then I'll paste the commands in the chat box. !SED dash I. So in the file, make file, wherever the string is GPU is equal to 0, we have to make it GPU is equal to 1. This slash GPU. In the make file, okay, so make file is not there. I have to go inside darknet folder. So %cd darknet to go inside the darknet folder, and then when I'll run the ls command, make file will be there. This is the file. The first thing is you have to enable GPU. After running this, comment it. Next is you have to make CUDNNS in place of 0 to 1. And then third is you have to make OpenCV as 1. I will paste these command in the chat box. And after running it, please comment these lines. So if you are running, you are installing label IMG tool right now, please do it after some time, because those steps are not required right now. Please run these 3 steps: GPU, CUDNN, and OpenCV as 1. So we are waiting for a minute so that you can also run these steps. So can't read file, you have to run this cd space darknet to go inside the darknet folder. Then you can run these SCD command. So I think we are able to run cd and then these SCD commands. After these steps, you have to create the executable build using make command. So you have to run !make. If everything goes well, it will take some time and create the executable build file. Please run these steps, SCD, these 3 SCDs, and then make. So if you are getting the error can't read make file, please run cd darknet and then you have to run these SCD commands. It will take some time to make the executable build. After this, you have to comment this line also. If you are able to run it, follow the next step. That is, you have to move the dataset folder inside darknet. Go to your Google Drive, you will having the unzipped dataset folder. Move it to darknet folder. So you can see now I don't have dataset folder here. My dataset folder is now inside darknet. Make sure you are having the dataset folder inside the darknet folder. You can see this is the folder. And inside dataset, I am having all the images and corresponding annotations. Yes, you have to move it manually by going to drive. You have to go inside your drive, move it manually inside darknet. So as you can see, my make command has been successfully executed. I am commenting this make command. Up to this part, if you are able to do, please write done in the chat box. Then we will move to the next part. Next is you have to prepare the some files, configuration file, so that it will be the YOLO V4 will be ready for your custom dataset. Please respond if you have done up to this particular part. Make sure the commands are correct. We have pasted the command in the chat box. It will be SED-I. Then this is the string. It will be searching for GPU is equal to 0 to GPU is equal to 1. And this is the file. Make sure there is a space after this single quote. There is a space. Then make file is there. If you will not provide space, it will give you the error that no input files. Next is when you will run ls command, you will find out that there is a file named as darknet. This is a file. Again, there is a query that it is showing no file or directory. Please check using ls command or using pwd. Please check you are inside darknet folder or not. If you are inside darknet folder, no need to run this cd command again and again. You can see I am inside darknet folder. So there is a file, this darknet file is there, which is having all the shell script for scripts to run the training, then testing, running with the videos. All the commands are inside this darknet folder. So to run this particular file, you have to make it executable. So that will be done by chmod command of Linux. Chmod, I'm using X to make the file executable, and then /darknet to give the path of this darknet file. Next is we have to create 3 files. One is the configuration file or the network of YOLO. The second is the file which will be having the path of the data set, path of the other related files. And third is the file which will be having the name of the classes which are there in the data set. So now in place of this particular notebook, you have to go to the drive which you have created, the folder you have created. Go inside the darknet folder. So we will explain you how you can customize the YOLO network for your data set. And then the final file is also there with you. So you can use that file also if you are not able to follow the steps. Go inside darknet folder, and then inside that there is a folder CFG, which is having multiple configuration files for different data sets, and different architectures are there. So we have to download YOLO v4 custom from this CFG folder, YOLO v4 custom.cfg. Download this. And then open it using any type of editor. Then you have to make some changes in this configuration file based on your data set. First of all, for training, make sure your batch size is 64. Subdivision for each batch is 16. You have to change the width and height from 608 to 416. It should be, this width and height should be the multiple of 32. So you have to make it 416. Next is this maximum batches. So this could be anything that is multiple of 32. Next is the maximum batches. So this particular maximum batches, it depends on your number of classes in the data set. For example, here we are having 2 classes. So the formula is that the maximum batches should be classes multiplied by 2000, but it should not be less than 6000. If you will multiply 2 by 2000, it will be 4000. So instead of 4000, I am writing 6000 because the maximum batches should be minimum 6000 by as per the official documentation. Then you have to change the steps. In line number 22, steps should be 80%, 90% of the maximum batches. So maximum batches are 6000. So it will be the 80% of the 6000 will be 4800, and then 5600. Till now you have changed four lines. Line number 8 from width and height are 416 from in place of 608. Then maximum batches are 6000. Number of steps are 4800, 5600. The 80% or 90% of maximum batches. Further, you have to make 3 more changes. I think in 6 places you have to make changes. The very first change is you have to search for classes. You can see line number 970. There are classes are 80. So it is for COCO dataset. In place of 80, you have to write 2 because there are 2 classes in your dataset. So at 3 places, you have to make classes from 80 to 2. Next is line number 1058. And third is line number 1146. So I'll wait for a minute so that you can also follow these steps. First of all, make batch as 64 if it is not 64, subdivision as 16, initial lines for training. Make sure you are doing the changes for training. Then you have to make height and width as 416, 416. Then the maximum batches will be 6,000, steps will be 4,800, 5,600. Follow these changes, and then at the end you have to, at 3 places, you have to make classes as 2 in place of classes is 80. After changing the classes variable, you have to change the number of filters just before the YOLO layer. So for that, again, I'm searching for classes. So this is YOLO layer. You can see line number 963, filters are 255. So wherever you will find that filters are 255, you have to make it. So the formula for filters is explained in the theory part, that it should be number of classes plus 5. Why 5? Because there are 5 annotations. 4 for bounding boxes, 1 for the class value. Multiply by 3 because YOLO gives you 3 anchor boxes. 1:1, 1:2, 2:1. So that's why multiply by 3. So classes plus 5 into 3. So in this case, we have 2 classes. Classes plus 5 will be 7. 7 multiplied by 3, that is 21. So filters will be 21. Not all the places. Make sure you are changing just before the YOLO layer. So first is line number 963. Filters will be 21 just before the YOLO layer in place of 255. This change you have to do at 3 places. Line number 963. Then line number 1051. Make 255 as 21. Again, make 1139 from 255 to 21. So at 3 places you have changed classes, and at 3 places you have changed filters. If you are able to do this part, please let us know in the chat box. If you are finding it difficult, then also you can let us know. If the pace is high, then we can try to explain again and again. So our configuration file is ready. Next is I'm renaming it. I am renaming this particular file as wildlife.cfg. Next is I'm creating 2 more files. One will be having the name of the classes. So there are 2 classes. First is tiger and second is peacock as per the annotations we have done. So I'm writing these 2 classes separated by line and saving in a place so that later on we can upload it. So it will be wildlife dot names because it is having the names of the classes. Next is I am creating another file. These files are already provided to you. If you are not able to run these commands or follow the steps, you can use the shared file. Download it from the shared folder and then you can upload it in your drive. Next is the data file which we have to create. With it will be having the other details. The very first detail is the number of classes. So classes will be 2. Then you have to provide the path where you are having the path of the training data. The training file will be there. So we will upload the training file in the data folder. So train inside it, train.txt. Similarly, for validation, the valid file we will again upload in the data folder. Then the names file which you have created. So names file, again it will be inside data folder, wildlife dot names is the name of the file, and then the folder which will be having the weights saved, the partial trained weight saved. Backup is equal to backup slash. So this is the file which we will be saving as data file, wildlife dot data. These three files you have to create. I'm pasting the content of the file. So the file named as wildlife.names, it will be having two lines. The first line will have tiger and second line is peacock as the object. The second file, that is wildlife.data, it will be having classes is equal to 2, train, valid, names, and backup path. Please create these two files. The configuration file you have already created. If you are not able to follow the steps of configuration file, use the shared file. I'll explain you that also. In the shared drive, day9 folder is there. From there, you can download the train.txt, test.txt, wildlife.cfg, wildlife.data, and wildlife.names. You can download all these files. And I am also downloading this MP4. That is a video in which we will predict the object. It will be having the bounding box in that particular file. So please download train.txt and test.txt. I'll explain what this file contains. So in the train.txt and test.txt, we are having the path of images which are being used for training and testing. So dataset slash img1.png, these are the images which will be using for training, and similarly in the test we will having the path of the images which will be using for testing. Train, test, CFG, data and names. Now we have to upload these files. Please download these files from the shared folder if you are not able to create these files, and then we will upload these files. Inside Darknet, go to data folder. Go inside Darknet, then data. In data, you have to upload 4 files. Test.txt, train.txt, wildlife.data, and wildlife.names. Upload these 4 files in the data folder. And then the configuration file will go inside the CFG folder. You have to upload 5 files. And then if you want to test the performance on video as well, please upload the video in the either dataset or darknet. I am uploading this video inside darknet folder. Directly inside darknet folder. You can upload anywhere, but make sure you have the path. So up to this part, if you are able to follow the steps, you are able to upload the files, please report in the chat box. Are you able to upload the files? If you are not able to make the changes, download the files from the shared drive and then upload. I am waiting for a minute or 2 minutes so that you can do the steps. Download these files. 5 files are there, which you have to download and upload. Text files, data file and names file will be inside data folder. CFG file will be inside CFG folder. After uploading, please report in the chat box that you have uploaded the files. These are the very basic steps, but for the very first time, it is difficult to make the changes. So that's why we have provided the complete files that you can use. And later on, if you will practice these for your data set, you can able to run the YOLO V for your data set as well. This drive things are completed, the upload part, creation part. Unable to download CFG. So when you will download the CFG file, it will give you some warning that it can harm your system, but you can keep the file. It doesn't having any type of harmful content. When you will download, so for example, I'm downloading this particular file. My system will suggest me that it can harm the PC. So you can see was blocked because of this type of file. So by clicking on this more action menu, you can keep the file. So then your file will be downloaded. The CFG file will be uploaded inside CFG folder. Other 4 files, that is train.txt, test.txt, data extension and .names extension will be there inside the data folder. 4 files inside data folder, CFG file inside CFG folder. And then you can download the image and the video provided to you to test. Or you can download any image or video from the internet which is having either tiger or peacock in the picture or video, and then you can test the performance in the downloaded file as well. Upload the CFG file inside this CFG folder. Upload other 4 files, that is train.txt, test.txt, wildlife.data, wildlife.names inside this data folder. And then you can upload the video and then image directly inside darknet folder. No need to upload anywhere else, or you can, if you want to upload somewhere else, you can do that also. But make sure you are having the path. I'm directly uploading in darknet folder, which we have cloned. Can we go ahead now with the training part? If you are done till uploading, please respond. Can we go ahead? So inside darknet, you have uploaded data set. This make sure you are having data set. Inside data set, you are having the PNG files in the corresponding annotation. Then inside data folder, that is the folder you have cloned. You have uploaded 4 files: wildlife.data, wildlife.names, test.txt, train.txt. And similarly, in the CFG folder, you have uploaded wildlife.cfg file. Next, you have to start the training after uploading these files. But as I am working on Windows and this is a Ubuntu platform, you have to make sure that you have converted the files you have created from Windows to the Ubuntu environment, because the files, the storage type of files are same, that is txt or data or name, but the back processing of the storage of the files may be different for both the operating systems. So you have to make sure you are converting the DOS created file to the Unix supportable file. So for that, I am installing a package sudo apt install DOS to Unix. I'm pasting the commands which you need to run in the chat box. After installation, you have to convert the file from DOS to Unix. The very first file is data/train.txt. Next is DOS to Unix data/test.txt. The third file is data/wildlife.names, then data/wildlife.data, and then DOS to Unix cfg/wildlife.cfg. These are the files which we have uploaded. I have pasted the commands in the chat box. Please run these commands. If everything goes well, you will see that converting file to Unix format. You will see these responses. If there is any error in the name or path of the file, you will encounter the error. And then I will comment this particular line, and then I'll also comment this sudo apt install. So this is the path or link of the official darknet repository, which will be having the pre-trained weights of dark YOLO v4. So we are going to use the pre-trained weights to start the training so that you will have better performance. So you can see YOLO v4.con.137 is the pre-trained weights. When you will search for this YOLO v4.con.137, you will find out that Google Drive mirror is there. I am copying the link, copy link, and then I'll paste the link in the chat box. We have to download the pre-trained weights, so that will be done directly by the command. So I'm writing wget and then pasting the, I think I have to, it's giving 404 error. These are the steps which I have explained. So you can also use the official website. It is giving error. So I'll paste the path which I have. github.com/LXCAB. I think it is there. This is I can use this particular link. You can also use this link to access the pre-trained weights. Please run this line. I have pasted the command in the chat box. Please use that particular command and download the pre-trained weights. Up to this part, if you are able to run, please respond so that we can go ahead. Okay, so now we have to train the YOLO V4 custom model that we have created using that CFG file. So for training, you have to run the command exclamation mark ./darknet. Darknet file, we have earlier made it executable from this particular command. And now we will use the file ./darknet detector space. As we are training, so we have to write train. And then parameters, you have to pass the path of the data file. So data/wildlife.data is the file. Then you have to pass the path of the configuration file, cfg/wildlife.cfg. And then you have to pass the path of the weights you have just now downloaded. So it is downloaded inside the current working directory. So I am directly writing yolov4.con.137. And as this collaboratory environment doesn't pop up a window, so you have to pass the parameter as don't show, otherwise it will give you error. If all the steps of this particular command is correct, then it will start the training. If there is any error while executing the earlier commands, it will encounter error or the training will not start. I'm pasting the command chat box. Meanwhile, it is executing in my system. So you can see, first of all, it will tell you what are the hyperparameters, and then it will explain you what are the layers present in the YOLO V4 architecture, which you are going to run. Then now you can see the training has started. But when the very first step will be completed, you will see that the loss is 2004. And the average loss is again same because this is the very first step. And it will tell you after first iteration, it will tell you how much approximate time it will be needed to successful training. So you can see now the average loss is decreased, and some other IOU and the number of boxes it is predicting, number of images it is working on, it will show you multiple results. And you can see it is showing you that it will take some 16 to 17 hours to successfully train the YOLO V4 in the given dataset that is having only 48 images. If your dataset is large, it may be taking some 40 or 50 minutes to train the model. So now I am stopping the training because we don't have that much of time to run the model. I'm stopping the training. I already have trained the model for some 2000 iteration. I provide you the shared link. I'll share the link, which we will use to test the performance. So let me share the link of the trained weights. So when I have trained the model, the partial weights are saved inside the backup folder. So when you will train your model on your dataset, the weights will be here. Initially, it stored the weights after 100 iterations, but when 1000 iterations are completed, it will save for each 1000, for 1000, then 2000, then 3000. So I'm sharing the weights, the last saved weights. You can open the file. Please open the shared link. Please open this link shared in the chat box, and then we will add the last saved weights in the backup folder. Click on this organize window when you will open the weights. Click on this organize window on the right side, then go to the place. Let me tell you in a private window because it is already in my drive, so that's why it is not giving me access to change the path. So first of all, you have to sign in, and then you can create a shortcut of this particular add shortcut to drive option is there. When you will open in the manage tab, add shortcut is there. So I'm adding the shortcut in the current folder. Inside darknet, I'm creating the shortcut in backup folder. So now when I will go to the newly created folder, that is day 9 AIML, inside darknet, backup, and then you can see a shortcut is there. So create a shortcut in your drive, or you can download the weights and then upload the weights in the backup folder. Now we will use these weights for training. So I'm copying the complete command. The only change you have to make is, in place of YOLO v4.con.137, you have to write backup slash it is wildlife underscore last dot weights. So it will start the training from where the last training was stopped. Maybe around 2000 iteration earlier I have executed. So you can see now training has started. It has started from 2100 iteration. I'm stopping the training. It was just to tell you how you can start the training after some iterations. 2100 iterations I have completed. Earlier, the loss was 2000 when you have started from the very first iteration. Now, after 2100 iteration, the loss is 0.88. So you can maybe train for some 1000 more iteration. Then the training can be stopped finally. Next is, you can test the performance on a new image. So for testing, the command is same. In place of train, you have to write test. This particular command will be same. This CFG will be same. The only thing is, you have to pass the path for the image for which you want to predict. Let me first of all paste the command in the chat box, and then I'll tell you how you can test the performance on a new image. So here we have to provide the path of the image. I think I have uploaded a test image with the video. So the image is tiger peacock test.png. If the training is successful, it will tell you. So you can see it is saying that there is a tiger with 99% of confidence score. Similarly, a peacock is there with 99% of confidence score. And then the prediction will be saved in the darknet folder. You can see this is the prediction. I am opening the image. It will be having two bounding boxes. You can see this. It is predicting it is a tiger and this is a peacock. This test image I have downloaded from the internet, and it is not from the actual training samples. After prediction, you can also calculate the mean average precision. That is a performance measure for object detection technique. So for YOLO, to calculate the mean average precision, you have to write ./detector. First of all, let me, I think, paste the test code, and then I'll tell you how to calculate mean average precision. So in place of this train or test, you have to write MAP, and other steps will be same. Let me run it. So you can see it is telling me that for tiger class, it is predicting 100% correct for test data. For Peacock, the average precision is 85 and overall IOU is 81.07 and 92.86 is the mean average precision for this particular data set. I'm pasting the result is stored in the darknet folder. This predictions.jpg is the result. Let me run the last command, then I can help you with the issues you are facing. The last is to predict the bounding boxes for videos. So /darknet detector, in place of map, train or test, you have to write demo. And then after weights, you have to write the path of the video, that is tiger_peacock.mp4. Then you can rename the output file. So I'm writing output out_file name is the parameter, and I'm storing it as result.avi. It will read the video and predict for each frame of the video. It will predict the. It is saying that video stream has stopped. Maybe there is some issue. Let me check it. It is MP4. I have just write MP. So it was not able to read the video. So now it is started predicting on the video as well. I'm pasting the command for video. And then the output file is results.avi that will be stored here in the darknet folder. It may take some time because it's a video. So to store the video, this can take some time. Meanwhile, I'll try to resolve the issues you were facing earlier. There was some issue that you are no such file or directory /darknet. So if you are facing, I think Mahadevi Singh, Mallika Shri Mahadevi Singh, ma'am, you can just run ls command to check whether you are inside darknet folder or not. If you are not inside darknet folder, this is the file, this darknet. If you are not inside darknet folder, make sure go inside darknet folder using /darknet %cd command, cd space darknet you have to write, and then run ls command. I have stored result.avi is there. Okay, so I have not its file name. I have to rerun it, and then it will save the partial or final output. So it is predicting for multiple frames. It is predicting peacock, and for some frames, it is also predicting tiger initially. Let me see if result is there or not. So this is the file result.avi. I'm downloading it to explain how it is predicting, or maybe it will run directly. So you can see it is a video from YouTube I have downloaded. You can see on video also it is predicting. For some frames it is missing, but for most of the frame it is able to predict. So I have completed all the steps required for YOLO V4. If you are having any issue, please write in the chat box. This particular notebook and the all the supporting files are there in the shared folder. You can use it. Or if you are having any issue later on when running the code, you can mail me on my mail ID.
Ma'am.
Yes.
Ma'am, after that, re-entering the darknet folder by cd command, I got this error, permission denied.
So I think you have not executed ch mode. Earlier we have
Sir, ma'am, I have executed that
this particular line, ch
earlier.
mode plus x./darknet.
Ma'am, could
First
it
one,
be a I runtime disconnect or something, because
yes,
all the things have.
you have earlier deconnected from in your drive, you have to rerun all the codes.
Okay, ma'am.
Any other issue? So I'm stopping the share. Ma'am, I have completed